All right, so this lesson we're doing how do we solve absolute value equations? Yeah, that's right, absolute value equations. Well, what's an absolute value? That's the distance a number is from 0. So if we think about the numbers 5 and -5, these have the same absolute value because they're both 5 units away from 0. The absolute value of 5 is equal to the absolute value of -5, and it's all equal to 5. So before we get into this, I want you to consider, whenever we're solving, let's consider the absolute value of x equals 3. Well, we don't know that x could either be +3 or x could be -3, because both of those are 3 units away from 0. So in general, when you're solving the absolute value of ax plus b is equal to c, set ax plus b equal to +c and ax plus b equal to -c. All right, let's look at some examples. All right, in this first example, we have the absolute value of x minus 5 is equal to 7. So my first step is going to be to write both of the equivalent equations. Those would be x minus 5 is equal to +7, or x minus 5 is equal to -7. And now we can just solve each of these for x and simplify. So on the left here, if I add 5 to both sides, I get x is equal to +12, or adding 5 over here, x is equal to -2. So the solution to this absolute value equation has two solutions, 12 and -2. All right, let's try that one more time. Here we have the absolute value of 5x minus 10 is equal to 45. So I'm going to write out my equivalent equations. 5x minus 10 is equal to +45, or 5x minus 10 is equal to -45. Solve both equations. So add 10. 5x is equal to 55. Dividing by 5 gives me x is equal to 11. Do the same thing over here. Add 10. 5x is equal to -35. And after dividing by 5, we should get x is equal to -7. Now we can check our solutions by just plugging these values back into our original absolute value and making sure that the absolute value would come out to a positive 45. But the absolute value is always going to be positive anyways. So my final answer is x equals 11 or x equals -7. Okay, when we have an x outside of the absolute value, we have to check for extraneous solutions. An extraneous solution is an apparent solution that we have to reject because it doesn't satisfy the original equation. And I think you'll see that in an example here. So let's just jump right into that. All right, so here we have the absolute value of 2x plus 12 is equal to 4x. So we're going to go about this the same way, but notice that we have this x that's also outside of the absolute value. So I have 2x plus 12 is equal to +4x, or 2x plus 12 is equal to -4x. I'm going to go about this the same way. Now, here I need to get my x's together, so I'm going to subtract 2x from both sides. And I have 12 is equal to 2x. Divide by 2. And x is equal to 6. Or I can subtract 2x from each side over here. 12 is equal to -6x. Divide by -6. And now I have x is equal to -2. So here are my two solutions, and I have to check to see if either of them are extraneous. It's not necessarily that one of them will be, but we have to check. And we check by plugging them back into the original. All right, so let's start with this x equals 6. It'd be 2, the absolute value of 2 times 6 plus 12 is equal to 4 times 6. So 12 plus 12, the absolute value of 12 plus 12 equals 24. I think here that's pretty apparent. 24 equals 24. All right, so let's check with the other one. Okay, the absolute value of 2 times negative 2 plus 12 is equal to 4 times negative 2. So we have the absolute value of negative 4 plus 12 is equal to negative 8. Well, here we already have a problem, but we'll finish it out. Here, the absolute value of 8 cannot be equal to a negative. An absolute value will never be equal to a negative number. So this negative 2 is extraneous. So we reject this solution. The only solution to this absolute value is x equals 6. All right, and that's how we solve absolute value equations. All right, I'll see you later. Goodbye. Next time.